welcome you to part 4 of worked out problems in projection of lines. So we'll start with a problem. Line PQ has its end P 10 mm above HP and 30 mm in front of VP. The other end Q is 35 mm in front of VP, and its distance with HP is not given, and the front view of the line is 75 mm long. The distance between the end projectors is 50 mm. Draw the projections of the line and its true inclinations with VP and HP. So this is a typical problem where you would be using the plane rotation method, because the hint for this is the distance between the end projectors, and you are not given the true length here. So let's start by looking at the technique, how this could be done. What you see on screen is a typical setup where you use a plane rotation technique, or this is solved using a plane rotation method. To know more about the plane rotation method, please refer back to our earlier video on plane rotation technique, which gives you a very clear explanation using animations. So here we, as usual, the technique is to start drawing the XY line, positioning the points A dash, A, B and B dash, B. So as per the question, this distances are given for the end A, as well as one of the distances for end B is given, that is the distance with VP is given for end B. Whereas to locating B dash, the extra thing given is that the length of the front view. So since this point is already located and you know the length, you can easily position B dash. And in this particular case, you have both the position of A and B, so you locate AB. So you can draw AB. So the critical thing to consider here or know here in plane rotation method is the method of drawing the true length. How do you draw the true length? Suppose you know one of the projections. So basically this distance, if you look at the plane rotation method, we know that this distance will be equal to this distance, and this distance will be equal to this distance. Similarly, this distance will be equal to this distance, and this distance will be equal to this distance. So if you know one of the views, or if you draw one of the views, you can immediately draw the true length in the other side by projecting the points perpendicular. The only thing you need to consider here is this should be perpendicular to the view. Similarly, this should also be perpendicular. All these lines are perpendicular. So this basically, it's kind of a trapezium. It is two parallel sides and two sides which are inclined to each other. So simply project, for example, if to draw this A1, B1, what you do is take this distance from the other view, draw it perpendicular to this line, mark point A1. Similarly, take this distance, project it perpendicular, mark B1, join them, you get A1, B1. You can do the same on the other side with these distances. And the critical data which you require in plane rotation method is the distance between the end projectors. These are the end projectors, and the distance between them is a critical thing. In this problem, it is given as 15. Okay, with this in mind, now let's try solving the problem directly. And before doing that, I'll also like to point one more thing. So here we are also trying to see, especially in the next problem, how to draw the vertical trace and the horizontal trace. They are nothing but the extensions. When you extend the true length and the corresponding view, you will get one of the traces. For example, here if you extend this true length and the front view you get the vertical trace, and similarly this true length and the top view you get the horizontal trace. Traces are very easy to draw using plane rotation method. Obviously you have a technique to do this in line rotation method as well, so which we will see later on with the example. So let's jump right into the solution. So we'll start drawing the XY line first. As per the question, we'll mark the position P dash and Q. The distance between the end projectors is 50 mm. And now we projected Q to the other side. And the front view distance is given as 75 mm, which is marked by cutting on the projector, and where it cuts, that will be Q dash. So you simply join this point to P dash and you get P dash Q dash. Now we have got the two views. So as we explained before, now it's a question of simply taking the distances from the other view, distances from XY of the other view, and using it on this particular view. For example, this on this side you will be taking the distance 20. So for example, the distance 20 will be taken and drawn from P dash. So P is marked at 20 mm from P dash, and Q, capital Q, is marked from 35 mm from Q dash. And simply join P and Q and you get the true length on that side. And you also directly get the inclination there. So you draw, again project the distance. 10 mm is projected on from P. And for Q, that distance from Q dash to the XY line, that distance is marked. So you can see that similar markers are given on each projector line to make it clear which distance is which, or which distance is taken for which, drawing which of the true lengths. So now we have got both of the true lengths here. And then that's how you construct a plane rotation technique. So here we are not showing the drawing the vertical and horizontal trace, since that is not required as part of the question. So we have found the inclinations. So the inclination with HP and VP are found as 47 and 11 degrees. So we'll move on to the next question. Now let's look at problem number 6. So the question reads like this: the end R of line RS is 25 mm below HP and 45 mm behind VP, while the other end is 50 mm above HP and 20 mm in front of VP. The distance between end projectors is 50 mm. Determine the true length inclinations with HP and VP and the traces. So it's a straightforward question. The only difference compared to the last question is that here the lines are oriented from different quadrants. The endpoints of the lines is oriented in different quadrants. For example, if you look at the end R, that is below HP, and the end S is actually above HP, and at the same time the end R is behind VP and the end S is in front of VP. So basically you can easily assume that, or easily understand that the end R is in the third quadrant and the end S is in the first quadrant. So you could visualize a line starting from the third quadrant and piercing through the vertical and horizontal plane and going up in the first quadrant. So that's how it is lying. So it's an interesting question, and there are some things you need to consider while constructing such a problem using plane rotation technique. So let us quickly jump into the solution. So initially you mark the positions endpoints R and S. So you could see that the top view of R is above XY and its front view is below XY, since R is in the third quadrant. So the distance between projectors is drawn here, and you can see that S dash, the front view, that is above XY since it is in the first quadrant, and S is below XY, again it's in the first quadrant. So R and S are joined, R dash and S dash are joined, so they cross each other, which means it is piercing through the vertical and horizontal plane. So you take the corresponding distances, that is for R, you take the distance from R dash, and for S, you take the distance from S dash and project perpendicular and join capital R and S. So that's the distance, that's angle of inclination with HP. And again, now we have drawn that from R dash and S dash. So the critical thing to keep in mind here is the distances that projectors have to be drawn in opposite directions here. You could see that here, if you're drawing from R dash in one direction, from S dash it should be in the opposite direction, since the line is crossing each other and they are in different quadrants. So now we have got R2, RS, two true lengths with respect to the two projections. You have also got the inclinations directly. Now to find the traces, what you do is instead of extending, so here we need not extend anything because already they are crossing each other. So you can very easily mark VT and HT here, since they are already crossing each other. Then no need to extend them. So this is also another thing which you will have to keep in mind. To find VT or HT, normally what we do is we extend the views so that they meet, but here already they are crossing each other. That is, the top view and the corresponding two lengths are meeting here as well as here. So which means we already get the vertical and horizontal trace. Vertical trace is obtained by finding the point where the true length and the front view meets, And similarly, the horizontal trace is where the top view and the true length meets. So that is the solution for this question. Thank you.